Today we start solving one-step equations, this is a very important section for us. And I want to start off by talking about this idea of balance or equality. Because when we're talking about an equation, an algebra equation, this idea of balance and equality are very important. You all grew up and probably at some point in your life got on a teeter-totter. And if we think of the teeter-totter, the fulcrum of the teeter-totter as being the equal sign, if I put on the right side 3 5-pound medicine balls or weight plates or dumbbells or something, if I want it to stay balanced, then I have to have 3 5-pound medicine balls on the left side. Now, if I happen to take one of those medicine balls off on the left side and I still want it to be balanced, what do I have to do? I have to take one off the right side, because if I don't, if I only take this one off on this side, then the right side is going to be too heavy, all right? And it will not be balanced anymore. Well, when we think of an equation, that's what we're trying to do. We're trying to keep this thing balanced or equal, okay? Equal. Okay, we want to keep this thing equal. So I have 3 keys for you to solving equations. 3 keys for solving equations. Number 1, what I do to one side of the equation, I do to the other. If I add 7 to one side, I must add 7 to the other side. If I subtract 10 from one side, I must subtract 10 from the other side. Second key. Use opposites to move terms from side to side, we'll just say. And you'll see what that means in a minute. We're going to use opposites to move things from one side to the other. And then the third key is more of a focus. All right, this is kind of my goal when I'm solving an algebra equation, not algebra equation, is to get the x by itself, or whatever that letter is. It could be an N or it could be an R. We want to get that x by itself on one side of the equal sign. These 3 keys are very important, and we're going to use them over and over again. So let's get started with some problems. Best way to learn these is to do them. And it's going to be real important that we show our steps and do not do these in your head. First one, x minus 8 equals 17. Now think back to our teeter-totter. I want to keep this thing equal. So what I do to one side, I must do to the other. Now, one of my keys said that I want to use opposites to move things to the other side. I'm trying to get the x by itself. So to do that, I need to move this 8 over here. If I'm going to move the 8, I need to use an opposite or an opposite operation. Isn't this a negative 8? So what's the opposite of a negative 8? Positive 8. So if I use a plus 8, or if I add 8 to both sides, look what happens. On the left side, and this is exactly the way I want you to write it. I don't want you to write it off to the side someplace. I want you to write it below like I did here. If I use a plus 8, negative 8 plus 8 is 0. Those two go away. And on the left side, I just have an x, which is the whole point. Now we started with an equal sign. We want to finish with an equal sign. X equals, what's 17 plus 8? 25. And we've just solved our first equation using algebra steps. Now I'm going to give you one to do, a very simple one, but I want you to use the same method. 10 minus 6 equals 14. Use algebra steps to solve that one, and I will pause the video. Okay, everybody did a good job from what I could see. We're going to use a positive 6, or we're going to add 6 to both sides. Going to make these two go away, and equals 20. All right, good easy example to start with there. Let's move on. What if I have 10 plus 6 equals 18? Well, again, I'm trying to move this 6 over here. So to do that, I'm going to use an opposite. The opposite of a positive 6 is a negative 6. So I use a negative 6 on both sides. On the left side, these 6's go away, and I have n equals 12. Now, we are going to have to deal with negative numbers. So let's start getting to some examples where we have to deal with negative numbers. Y plus 7 equals negative 9. This problem, believe it or not, as easy as it looks, a lot of people struggle with because they forget how to work with integers. Aren't I going to use a negative 7 on both sides? So if I use a negative 7, the left side, the 7's go away, and I have y equals. But the right side, a lot of people mess that up. This thing right here, you need to remember your rule. When the signs are alike, you add the numbers, and you keep the sign. If you're in a 9-foot hole, and you dig down 7 more feet, you're going to be in a 16-foot hole. So my answer is y equals negative 16. How about this one? X minus 8 equals negative 3. Lots of different ways these can look. So we're going to do a bunch of examples today to try to get you ready for homework. So what am I going to do to both sides? I'm going to add 8. On the left side, the 8's go away. On the right side, what is negative 3 plus 8? Positive 5. Good. Trying to expose you to all the situations that you might see. N plus 11 equals 4. I'll pause the video and you try that one. All right, we're going to use a negative 11 on both sides to move this 11 over here. That's going to make it go away on the left side, so n equals negative 7. Now, sometimes people get confused with the way problems are set up, and I just want to go over some of those. What if the problem is written this way? 2 equals 5 plus x. Well, let's think about what our focus is. We're trying to get x by itself, which means which number do I need to move to the other side? The 5. This number is the one that needs to go to the other side. So that's the one I need to use an opposite with. And I don't look at this sign. Don't look at that, okay? look at the sign here to the left of this 5, and this is a positive 5. So we are going to use a negative 5 on both sides to move that 5 over. All right? So the 5's go away, and on the right side I have my x by itself that I want, and on the left side I have 2 and a negative 5, which makes negative 3. Lots of different ways these can look. Here's another way they can look. Negative 5 equals n plus 13. If the n's or the x's are on the right side, it doesn't mean anything changes. It just means the location is different. So what am I wanting to move to the other side? The 13. So I'm going to use a negative 13. Remember, I want n by itself. So the 13's go away. On the right side, I just have an n. On the left side, negative 5 and negative 13, my signs are alike, so I add them and keep the sign, negative 18. Now, every once in a while, you may have this situation. 13 minus y equals 8. Now, this one's a little bit different. Somebody asked about this one a minute ago. What happens if the x or the y is negative? That's what I'm going to show you on this problem. There's a couple different things that we could do. All right. I think for now it would be easier to make that variable positive by adding it to both sides. If I add y to both sides, I now on the left side, these y's go away, and I have 13 equals y plus 8. And doesn't it already look a lot better? Doesn't it look like a pretty easy equation to finish now? If I want to solve for y, what would I do from this point? I would just subtract 8. So those 8's go away, and y equals 5. By the way, I know that looks like it says 5 equals y. It does. But I can say it 5 equals y, or I can say y equals 5. There's a property for that. It's called the symmetric property. The symmetric property allows me to flip sides like that on the equal sign. Okay? Let's keep going here. What about this problem? Negative x plus 3 equals 9. What did I tell you to do on the last one? Didn't I tell you to add that negative variable? Right? Let's do it again. Let's add the negative variable. Let's add the x to both sides. If I do that, it gets rid of the negative in front of it. So that goes away. And now I have 3 equals x plus 9. I could have written 9 plus x. It would be the same thing. So then I need to move which number over to get x by itself? The 9. So I'm going to subtract 9. Goes away on that side. And I just have an x. On the left side, 3 and negative 9 make negative 6. By the way, how do I know what to slash? If I slash these situations where I have a positive 9 and a negative 9, or up here, the positive 8 and the negative 8, okay? Remember, we're trying to get the variable by itself, so that's the number that I always move. We're almost done. We just have another example or two. How about negative 4 equals 1 minus x? I'll pause the video and you try that one. All right. we have a negative x, so we need to add x. Now, a lot of people struggle. They'll do that step correctly, but then they don't know how to write the next line. So let me kind of go over that. First thing you always want to start with is an equal sign. Okay? The next thing is on the right side, do you see the opposites here? Those opposites are what go away. So now on the right side, the only thing I have left is a 1. On the left side, we added x to negative 4. Now, you might think, well, isn't that negative 4 plus x? Sure it is. And you could write it that way. But can't I also write this as x minus 4? Look at my signs. This sign is negative, this sign is negative. This sign is positive, this sign is positive. So you can write it either way and it would be correct. Okay? So now I have x minus 4 equals 1. And then you just add 4 to both sides. So x equals 5. All right? Let's do one more. This will be our last problem of the day. How about x minus 9 in parentheses plus 13 equals 80. Now, I know the title of our lesson was solving one-step equations, but technically this is a two-step equation. And the reason it's a two-step equation is because I need to move two things. All right, the first thing I need to move is the 13. So let's do that first. That's a positive 13, so let's use a negative 13. So now if you look for my opposites, I've got this positive and negative right here, so these two go away. And on the right side, 80 minus 13 is going to be 67. On the left side, the only thing I have left is this x minus 9, so I bring it down. X minus 9 equals 67. Just one more step. I need to move the 9 over, so I'm going to use an opposite. I'm going to use the positive 9, and I'm basically done. On the left side, I have my opposites right here, so these two go away. X equals 76. And we will stop there for today.